Good morning, seventh graders. How are we doing this week? So, moving on into our next week of content, we are still dealing with some of these proportional relationships and our constant proportionality, which remember can also be called a rate, a unit rate, or anything like that, rate of change, even. But now we are going to work when we have our lovely friends fractions involving our problems. So that's been our main change this week is that we're going to start looking at our different rates and ratios and rates of change when we have fractions in our problems. So without further ado, let's get to our examples in our
Right.
video.
Today, we're going to be talking about ratios of fractions and their unit rates. So it's just going to be a little different because we're going to start with fractions. So our first example, who's faster? During their last workout, Izzy ran 2.25 miles in 15 minutes, and her friend Julia ran 3 and 3/4 miles in 25 minutes. Each girl thought she was the faster runner. Based on their last run, which girl is correct? And we can use any approach to find the solution. So I'm going to highlight some important information here because that's just how I'm going to know what I'm working with. So I'm going to highlight that Izzy ran 2.25 miles in 15 minutes. And I'm also going to highlight that Julia ran 3 and 3/4 miles in 25 minutes. Something else that I want to do is, so let's see, I'm going to try to make a table. So I know that in 15 minutes, I can figure out for 30, and for 45, I can even figure out for an hour if I wanted to. So that's our time in minutes. Minutes. Let's see. What if I try to think about this in terms of hours? So I want to know what is 15 divided by 60? So that'd be 15 minutes out of 60 total minutes for an hour, because we usually think of time, or at least rates with time, in terms of hours. Well, 15 over 60 is just 1/4, so a fourth of an hour. So then I'm going to have 30 over 60, which equals 1/2. 45 over 60, which equals 3/4. And let's just make some lines here. And then 60 over 60 just equals 1. So let's do that. So it's our time in hours. For Izzy, this is just for Izzy. I'm just going to make that I. So I know that she ran in 15 minutes 2 and 1/4 miles. So if she doubled that, so in 30 minutes, she will have ran 4.5 miles. For 45 minutes, if I keep doing 15 times 3, and if I do 3 or 2 and 1/4 times 3, I'm going to get 6 and 3/4. And then if I were to multiply 2 and 1/4 by 4, I actually am going to get 9. Okay, so what about Julia? Let's think about Julia here. So I'm going to do my time in minutes and then in hours again. Minutes, hours, D for distance, minutes, hours. So I know 25 minutes. I could probably figure out for 50 minutes. Could figure out for 75 minutes if I wanted to. So let's see, 25 over 60. Well, that's going to be 5/12 of an hour if I reduce that. And let's see, 50 over 60. Well, that's just 5/10, or 5/6, not 5/10, 5/6, sorry. 75 over 60 is going to equal 1 and 2/3. And I know that the distance for Julia is 3 and 3/4 miles for 25 minutes. If I were to double that, I'm going to get 7.5. And if I were to do that times 3, that's going to be 11 and 1/4. Now there's two ways that I can go about doing this. I can try to think about what is my constant of proportionality, or I could try to see if I can find a similar time. And I'm actually going to do both because I know that if I add another 15 minutes on top of 60, I'm going to be at 75 minutes. So that's going to be 1 and 1/4 hour. So after 75 minutes, I know that that Izzy has run 1:11 and 1/4 miles, and I know that Julia has also done that. So it turns out it seems like they're equally as fast. They make the same distance in the same amount of time, but what about trying to find my constant of proportionality? So let's think about it like this. I know for Izzy, it's going to be nice and easy. It's going to be my distance over my hours. So let's see. Whoops, I don't want to highlight. I want it to be distance over hours, which is 8. So for Julia, that was 9/1, or that equals 9. And I know that, sorry, that was for Izzy. I don't know why I keep messing up. That was for Izzy. So Izzy I. For Julia, however, I can just take any of these times because I know that it's going to be proportional. Um, just because I keep doubling things every time. So I'm going to use this original time up here. So 3 3/4 miles in 5/12 of an hour. So 3 3/4 over 5/12. So this means I have to divide by a fraction, which means that I need to end up multiplying by the reciprocal. But the first thing that I'm going to do is I'm going to take this 3/4, 3 3/4, this mixed number, and I'm going to make it an improper fraction, which means I need to do the 3 times 4, which is 12, plus my numerator 3. So I'm going to get 15/4 over 5/12. Now the only way I'm going to get rid of my denominator, or the only way that I can divide by a fraction, is if I multiply by the reciprocal. So I'm going to multiply the top and the bottom by 12/5. The bottom cancels out, and I'm left with 15/4 times 12/5. The nice thing about this is that this 15 and the 5, since they have a common factor of 5, they can actually cancel each other out, and I'm left with 3 instead of 15. So 3 times 12, since I can multiply fractions across the top and across the bottom, 3 times 12 is 36. And I keep my 4 on the bottom because that 5 is replaced with a 1. And 36 divided by 4 is actually equivalent to 9 as well. So it seems like they have the same constant of proportionality, and they ultimately run the same distance. So since they have the same constant proportionality, same k, that means they have the same rate. They are running at the same rate. So they are equally as fast. So they run the same speed. Awesome. And there's other ways that you could do this. You could try doing this with a clock. You can try doing this with an equation like I did. You could try doing this on a number line or anything like that. Okay, so there's many different ways that you can go about doing this. But let's move on to our next example. Is Meredith correct? Number 2, a turtle walks 7/8 of a mile in 50 minutes. What is the unit rate when the turtle's speed is expressed in miles per hour? So the first question is, to find the turtle's unit rate, Meredith wrote the following complex fraction. Explain how the fraction 5/6 was obtained. Well, in this case, I need to think about the bottom is going to be my time, and the top is going to be my distance. Let me make that t look a little bit better there. So the bottom is going to be time. So I know it's 5/6 is my time. And I'm trying to think, 5/6, how is this related to time? Well, I know that there are 60 minutes in an hour, and they were originally talking about 50 minutes. So I'm betting that 5/6 comes from 50 minutes over 60 minutes. So 50 over 60, 50 divided by 60. Well, if I divide the top and the bottom by 10, that gives me 5/6. So it's an equivalent fraction. So in this case, it comes from time. comes from the 50 minutes. Comes from the 50 minutes, okay? And we want to make sure that it's equal to, since 60 minutes is equal to 1 hour, 50 minutes can be written as 50 over 60 hours, or 5/6 of an hour, okay? So determine the unit rate when the turtle's speed is expressed in miles per hour. That means that we actually have to do this mathematics. So I'm going to have 7/8 over 5/6. And again, since I am dividing by a fraction, that means I need to multiply the top and the bottom by the reciprocal. So that cancels out on the bottom there, and I'm left with 7/8 times 6/5. So I can multiply across the top and across the bottom. 7 times 6 is 42, and 8 times 5 is 40. And since this has a common factor of 2, I'm going to divide the top and the bottom by 2 to simplify it a little bit more. And I ultimately get 21 over 20, which means, whoops, let's zoom in a little bit maybe. So I get 21 over 20. And 21 over 20 is going to be the unit rate. So that's our K, that's our constant proportionality, that is our unit rate. So if I apply this back into the context, I know the turtle's speed is 21/20 miles per hour. So again, the main difference in these problems was that we were just using fractions now. We wanted to become more comfortable with them. So our lesson summary, let me zoom back in here. A number written in a fraction form whose numerator or denominator is itself a fraction is called a complex fraction. So a fraction over a fraction, or if just a fraction on top or a fraction on the bottom, is a complex fraction. If a proportional relationship is given by a description such as a person walks 2.5 miles in 1 1/4 hours at a constant speed, then the unit rate is you would need to divide that distance over time, and you would ultimately end up finding that that person walks 2 miles per hour. So again, this week is really all about getting used to our fractions again and learning about our new term, complex fraction, which is when we either have a fraction in the numerator or the denominator or in both.